TIG welding, also known as tungsten inert gas welding, is a welding process that uses a non-consumable tungsten electrode. The welding polarity can be either direct current (DC) or alternating current (AC), depending on the material and desired results. Let's start with the welding polarity. DHAN, or direct current electrode negative, is when the electrode, tungsten, is connected to the negative terminal, and the workpiece is connected to the positive terminal. This polarity offers better penetration and heat concentration, making it ideal for thick materials like steel. It is commonly used for welding steel and stainless steel. On the other hand, DCEP, or direct current electrode positive, is when the electrode is connected to the positive terminal and the workpiece is connected to the negative terminal. This polarity results in faster electrode melting and increased heat on the tungsten. It is commonly used for welding aluminum and certain alloys. Lastly, we have AC, or alternating current, where the polarity alternates between DCEN and DCP. This polarity balances penetration and cleaning action, making it suitable for materials that form oxide layers. It is commonly used for welding aluminum and materials that require oxide removal. Choosing the right polarity is important. DCN is suitable for steel and stainless steel. DCP is suitable for aluminum and non-ferrous metals, and AC is suitable for versatile applications and materials requiring cleaning action. Always consult the welding machine's manual and consider material specifics for the appropriate TIG welding polarity. Now let's talk about TIG welding electrodes, or tungsten electrodes. These non-consumable components are crucial for generating the electric arc. There are different types of tungsten electrodes. Pure tungsten, which is green, is used for AC welding of aluminum and magnesium alloys. It has a pointed tip and is suitable for low amperage applications. Thoriated tungsten, which is red, contains thorium oxide and enhances electron emission. It is commonly used for DC welding of stainless steel and nickel alloys. Serrated tungsten, which is orange, contains cerium oxide and provides arc stability. It is suitable for both AC and DC welding, especially for thinner materials. Lanthanated tungsten, which is gold, contains lanthanum oxide and offers good arc stability and long life. It is suitable for both AC and DC welding. Zirconiated tungsten, which is brown, contains zirconium oxide and is often used for AC welding of aluminum. It is resistant to contamination and provides a stable arc. The size and shape of the electrode also play a role. There are various sizes and shapes available, including pointed, bald, and truncated, flat. The selection depends on factors such as welding current, material thickness, and joint configuration. Proper electrode preparation is crucial for optimal performance. Contamination should be minimized to prevent weld defects. Always choose the right tungsten electrode based on the welding application and material specifics. Refer to the welding machine's manual and follow the recommendations. And that's a concise overview of TIG welding and its important components. Happy welding!